Okay, guys. So for this example number 3, they're telling us the profit can be modeled by this function. So really probably have a p of x there, where x is the number in millions of shoes produced. Okay, and the profit is b. Yeah. The company right now makes 1 million shoes, and the profit they make is 25 million. But they want to cut back the production number of shoes they make, x. Okay. This question is asking what lesser number of shoes could the company make but still have the same profit. Okay. Let's visually think about this as an upside down, or it's not an upside down problem. Careful, Mr. Covey. It's a cubic. It's a cubic graph. Okay. It's got a negative leading coefficient, so its end behavior is going to be up, down. So I don't really know what this looks like. It might look something like this, maybe. Oh, it's just a guess. It's telling me that right now, oh, I know the y-intercept is 0. It's telling me that right now the profit is 25 million. But there's some other time when the profit is 25 million. So let's go with above 25 million, and it must be, I'm only looking at this quadrant because I only want them to produce a positive number of shoes. You can't make negative shoes. So at some point, 25 must be like right here, because it hits 25. They tell us that right now it's at 25, and they're asking me for the other time. Let's go to our calculator and see that. Okay, so I go to my y equals, I type in my equation, I hit graph. It's like, it kind of looks like this, but it's going way above. So I need to go to my window, and again, I can change it however I want. My x is the number of shoes produced. It's not going to be negative. Okay. It looks like my x over was fine. Like I was seeing it come back down, but you can change it if you want. My y is what was weird. That's my profit. I don't care about negative profit. My graph went higher than I could see, so I'm going to bump this way up. Maybe I'm going to bump up to 50. I don't know. I know that right now I'm making a profit of 25 mil, so it has to go above 25. Okay. Trying to figure out where it intersects with this line. This line is y equals 25. It's where p, which is my y value, is 25. So the other thing I'm going to type in is y equals 25. And now hopefully it looks like this. And it does. I definitely hit that y equals 25 there. It's kind of hard to see. So maybe I want to zoom in. You can always use the zoom in feature if you want. I'm not a big fan of the zoom in, personally. I like to just change the window. But you can use the zoom in if you want here. Like it's very clear, like I need to get a better picture of that. So hopefully now I can see a little better. Oh, this actually worked pretty nice. Trying to find these 2 points. That's where the intersect feature comes in. Okay, so remember, just go near one of the points of intersection. Hit enter, enter, enter. 0.7 has a y value of 25. So one of these x values is 0.7. Let's figure out the other one. Again, I'm calculating a point of intersection. Enter, enter, enter. 1. Okay. So there's 2 times, 2 number of shoes they could make where the profit would be 25 million. They're asking me what's the lesser number of shoes that they could make and still have the same profit? Well, this is the lesser number of shoes that they could make and still have a profit of 25. Okay, right now they're making 1 million shoes. They told us that in the question too. So it all makes sense. What lesser number could they make? 0.7 million. What's 0.7 million? 700,000 shoes. So they could alternatively make 700,000 shoes. Cool. Profit would still be 25 million.